The question is, can 4 signals be viewed on a 2-channel scope simultaneously? And the answer is yes. We have all seen AC ripple voltage on top of the DC signal level. So why can't we just have a DC coupled square wave and put another signal on top of that, such as it would look like this ripple? So we set up a 3 kilohertz square wave signal on the signal generator. Then we connected it to our Picoscope 2205, which is an educational version. That's why it has a different case. It was much cheaper back when I bought it. You can follow the generator signal cable down to this T connector, which is plugged into channel A of the Picoscope. And then we end up with this signal on the oscilloscope. Notice that this signal was captured at 200 milliseconds per division and then later zoomed in to get this view, which shows a little bit of noise on top of the square wave. That noise is from the generator itself. Then we set this generator up for a 30 kilohertz square wave, 50% duty cycle, and piped it down the cable. It's from one bench, piped it over to this other bench, and it comes in right here. You follow it around, and it goes to this little metal box, and that's a ceramic capacitor, 1.8 microfarads, rated at 250 volts. This AC coupling isolator box also connects to the T connector, which is connected to channel A of the oscope. And that 30 kilohertz signal by itself looks like this. Notice the horizontal markers in this view here. It's the bottom square wave looking shape is actually the 3 kilohertz square wave, and the markers show the beginning and the end of that 3 kilohertz square wave. Superimposed on top of this 3 kilohertz square wave are the 30 kilohertz square waves. And that's what you see. The long vertical pulses are the 30 kilohertz. And you can quite easily compare the relationship between the 3 kilohertz signal and the 30 kilohertz signal because they're both in sync. And you can decide what to sync with to get the view you're looking for. If the top signal was a crankshaft sensor signal right in on top of an intake camshaft sensor signal, then what you could do is you could sync on the missing pulses on the top part of the crankshaft signal to synchronize the waveform so that everything is steady. Now you can measure the relationship between the intake cam sensor and the crankshaft sensor on a single scope channel. One channel can look at both signals at the same time, and you can actually measure the difference once you stop the channel and zoom in on it. You might be tempted to not use the AC coupling capacitor, and this is dangerous because now you're shorting 2 different DC signal levels together, and that's not good because you could blow up your ECU or whatever. So it's best to always use the AC coupling capacitor to connect that second signal to the same scope channel. Of course, whatever you do with channel A can also be done with channel B. So this is how you can get 4 different signals onto a 2-channel scope and look at them simultaneously. We're going to have a follow-on video which does that. This is the same 30 kilohertz square wave signal right on top of a 3 kilohertz sine wave signal. So as you can see, the sine wave makes it pretty difficult to find the beginning and the end of the sine wave. So this concept works best when you're working with square waves.